Hi guys, I am Yuvaraj Maran, final year student of SVC, and I'm gonna give a brief introduction to Apache Maven. So Apache Maven is a software building tool used by most research developers around the world. So what we are gonna see now is basically a software management tool. It's used for building, reporting, and documentation. So why we go for Maven is because it provides everything at its central repository. So we don't really have to use all the things needed. We don't need to collect everything what we need. It is already available in that repository. So an overview of what we see today is I'll first introduce what is Maven, then we'll see the basic structure of the Maven and how it handles dependencies. Okay, so basically, Maven, as I said before, it is a software building tool, and in our college life, we are creating many projects for our labs as well as our final year projects, everything. So each and every project has its own set of dependencies and own set of requirements and all. So if you are in conventional method, you need all the dependencies to be included in your system for the jar to run. Jar you build using any tool to run. But Maven, what it does is it provides a way to remove all those jars and to make a standalone executable jar for your project. So basically, how it works is the basic skeleton of Maven will have archetype. So the main features of Maven will include handling dependency system. So as I said before, if you have multiple jars to be included in your project, such as an external library for your algorithm, such things, what you can do is you can just specify what jar you're gonna include here, and you can just use those class files inside the jar in your program. Maven, what it does is instead of importing the whole jar into your project, it just extracts the needed class files from the jar and includes in your project. So this reduces the space complexity of your project and also makes it independent of that particular library. And multi-module builds. You can also create a group of projects controlled by a single a class file. So this individual projects can also be executed individually, as well as they can also be integrated and executed by a single. The project structure will be consistent throughout the project, and the model building model is also consistent. Basically, Maven is a plugin oriented tool. So as for example, if you want to perform a special task, you can just include a plugin for that task, and you can just the task is over. Then project generated sites, such as the reports that you generated for your project, can be directly imported into the Maven repository, so that it will be available for others to use. So let's go into the basic project. How will you create a project in Maven? So okay, so for Maven, I already said about this archetype. Okay, so Maven, creating project using Maven will you can create it using IDEs like Eclipse, NetBeans. You can integrate it Maven into those tools, but I prefer using this command line because you will be familiar with what is the skeleton of Maven. Okay, so each Maven project is created from an archetype. So archetype is a Java file. Actually, Maven is a Java-based build tool. Okay, so as I said, Maven is a Java-based build tool. So each command we are mentioning here will be a class in Maven source. So this archetype is a class which will create the project you need, all the structure of the project, the folders, everything you need, and from the specified parameters. So generate includes, we need to generate a new project from the given parameters, and a group ID. Okay, so what group ID specifies is, in your project, if you're grouping a set of class files into a project, usually we'll use packaging. So in packaging, we'll use the folder structure. For example, svce.as.app implies that the class file will be present inside the folder svce. Inside the AS folder, again inside app folder, will have the class file. So this group represents the folder group in which the project will be created, and the artifact ID represents the title for the project. So this will be the home folder for your project, and these will be the subfolders of your project. And the artifact ID represents what kind of project do you want to create. A quick start project represents that no additional dependencies and no additional features will be included in your project. Just a basic, it will create a basic project. And interactive mode false represents that we are using a command line for creating this project. So as you see now, Maven, as I said before, Maven has a central repository. In that case, it has its own server for extracting the information required for building as well as compiling, doing anything requires the online online repository. So this, as you can see, it creates the artifact and group ID. Then this value snapshot represents the jar that is going to be created. So when we build a project using Maven, the initial version will be 1.0 snapshot. Okay. So this will be an executable jar which will include all the dependencies, and which will not require any external dependencies for the project. So we have successfully created our project. So let's look into the folder structure. So we have given example as ID. So example is the root directory for your project, and we'll have the pom.xml, which we are going to discuss in a short time, and this source will contain main and test. And we already know that each build tool will have defining file for the project is being built perfectly. So this main will contain Java, in which Java sources will be placed in this folder. And as I said before, the folder structure, as you mentioned in group ID, will be created here. svc is app, and you have app.java. So this app.java here will contain svc as.a package. Okay? So then it creates a class app by default. It's the default class from which you can control what are all the classes you're gonna insert for your project. So it's a simple project which prints hello world. Then here, coming to the POM file. Before going to the POM file, let's see how this dependency works actually. So let's see the app.java file so that you'll get a clear perspective view of the project. So this is the app.java file. So as I said, the package has been created in the name of the group ID, and it has created its default class, and it simply prints hello world. So now going for the dependencies, each project we do, as I said, as a dependency. So if it is going to be a jar or a library, which we need a certain part of that library to be included in our project. Usually what we do, as we use Eclipse, mostly we use Eclipse. So in that, we'll just import the jar and try to build the project. Then finally we create an executable jar for that project. So but that executable jar we create requires library to be in the location preferred when inserting it in the Eclipse. So this is a dependency for your system. If the jar you inserted is not present in your system in which you are running the jar, then it will be difficult to run this you run your project. So instead, we can here have okay. So instead, Maven has a repository for all the jar files. Okay, so okay, one Maven repository. So just a minute. I'd like to show what are all the kind of repositories existing for Maven. Okay. So, so as I said, this default central repository for Maven is repo1.maven.org/maven2. So this will contain all the required pre-existing libraries, jars for pre-existing libraries, the way to include them in your project. And these are the mirror repositories depending on user's location, US, UK, and different countries. So, um, so adding dependencies. Now we know what a dependency is and how we are getting this dependency. Now, how to add these dependencies to your project? What's the method to add that? For this, Maven provides a file named pom.xml. It's a project object model which describes how your project will be and what are all the dependencies of your project. Okay, so basically by default, while generating the project, it will contain the name of the project and the version. By default it will be 1.0, and the artifact type, in the sense, in this project we have given a quick start type, then source code location, the path for the source code location, and the dependencies, and also plugins. So as I said before, for certain tasks, plugins are used in Maven, as similar to Eclipse, instead of using different methods for them. And profiles. Profiles is an alternate build configuration in Maven, and this uses XML format by default. That is, the POM file will be pom.xml. So let's take a look at the XML for the sample project we have created. So this XML file, okay, this is the XML file that has been created for our project. So, if a header, so here, and the model version of the project group ID, the artifact ID, and what kind of packaging we are creating, and the version of our current package, the name of the package. So this URL represents the default Maven repository. Dependency includes, this is by default JUnit, Java unit. It's a basic dependency that is needed for all Java projects. And if you're gonna need some other dependencies, we can add them one by one. So I'll show how to add a dependency. Now, so as I said before, we have many kind of repositories for Maven. So let's take a look at Maven repository, where in Maven repository provides almost of libraries to use this Java driver. So, or I think many of you are familiar with Hadoop. Okay, the Hadoop is just a distributed and based MapReduce MapReduce application. Okay, so if you want to use such software like Hadoop in your project, you just have to type Hadoop, search for Hadoop. So it will give some Hadoop Okay. So sorry guys, there seems to be a disturbance in the broadcast. So as I said before, let's see how this repository works. I'll explain once again. So uh, this is how, for example, if you want to include Hadoop, Hadoop tool or package in your project, you just go search for Hadoop and what package, what kind of package you're going to include, select that, and you'll there will be a list of versions with the release dates. If you're going to use a specific version, select that version. Then it will automatically will give you syntax to include that in your package. So you just have to copy it and include it in your POM file. Okay. Then this is just adding a dependency. So this is, by this way you can add almost all the libraries that are existing in present scenario. Mostly used libraries are mentioned here. So in case if you're gonna use a new jar, maybe developed by yourself or your friend in your project, so what should we do now? For that also Maven provides a simple solution. So it's just much simpler. Okay, so before that, let's take a look at repositories. I have said about central repositories. There's also other two kind of repositories. Okay, so the central repository is will be stored in the server and is a collection of all kinds of libraries available. A local repository is the one where the files from the central repositories will be stored in your local cache for your project in case if your connection is lost. So this local repository is kind of two types. One is system based and the other one is project based. So initially, let's have a look at system based repository. So basically this system based repository in Linux will be stored in the root users file with a folder named .m2. Okay, based on the version. So within a .m2 you will have one folder and a file. As usual, a settings file for specifying what will be the central repositories and what will be the settings for the current Maven version, and the other one, the folder, the source files, which will contain all the files, libraries we are going to use in your project. So we'll see the local repository now. So as I said, it will be in the folder .m2 here. So if you list it, we'll have repository for a folder named repository and a file name setting.xml. So this settings.xml, this settings.xml will have specific setting parameters for configuring the XML file. Sorry, configuring the Maven. So as you see, so here it also provides some syntax for modifying the proxy in case if you are using, say, your college proxy or any other network where proxy is required. We can just include the proxy using active tag as true and the protocol type and the host and ports. If present, username and password, otherwise the default passwords. Okay. So then profiles. So each profile will represent maybe additional dependency or a repository and many other things. Here, ID standard extra repositories include what are the default repositories we are going to use in our Maven application. So here, the central repository represents, as I said before, repo1.maven.org /maven2, and the Cloudera repository is Cloudera is another repository where it provides similar kind of service as Maven repository, but with a different application. Like as I said before, this is a project based on Apache. So even Apache has built many libraries, many open source packages for many applications. Cloudera just improves those applications, and also it defines their own applications. And those applications start with CDH series. The current version is CDH5. So this repository will contain all the libraries developed by Cloudera as well as modified by Cloudera or improved by Cloudera. So Cloudera is a wonderful repository where even if there is a bug with a normal library, we can use a library from this Cloudera where it will be bug free, almost bug free, not entirely. Cannot assure that obviously. So this is the settings file which will contain the repository as well as the proxy information. Okay, the next step will be creating a executable jar out of this form file. Before that, we'll go see a glance about the project repository. Mostly, as a developer, we won't be needing project repository because project repositories were defined within the project. So those repositories will exist within the executable jar we generate. So the default folder will be within the source file. It will have a resources folder where we'll keep the jars instead of installing them in the local repository. So those jars will be present in the resources folder in your executable jar. So in such cases where you need those jars for reference or you need those jars, it is mandatory for you to need those jars. In that case, we can include those in the local repository, local project repository. So let's see about including a third-party jar in a Maven project. Okay, so including a third-party jar includes like if you have an executable jar, what it actually does is instead of installing your central repository, it installs in your local repository. So this implies that when a project is being created and compiled, you will the steps will include initially it will look into the project's local repository, then it will move on to the system's local repository, then to the central repository. So here installing a file includes you need to invoke the install package with the install file. So the file includes the jar name where I have used a test jar name with core psk.jar and group ID. So this is can be the user's choice. So here I given com.ericsson.correlation. So this is a correlation jar and the artifact ID includes the correlation and version includes what is the version of the project and packaging, what kind of package is that, is it a jar file or war file, something like that. So if this is given, what it does is it takes the jar, creates a form file for that jar and it includes it in the repository. So there seems to be inconfiguration in my location. I'm gonna move on. So it that happened because we are inside the actual local repository. So it is it will be inaccessible when a project when a folder is actually using it. It cannot be modified. Okay, so after installing this, you can just include it in your XML file. In this XML file, just like we can add as dependency with the name of the group ID we have given, which is com.ericsson.correlation. Here the artifact ID name, the version, and its scope. Okay, so okay, so now let's see some commands of Maven. So basically, Maven has uh, basically it has 6 operations. Which will include, which is called as a growth. Okay, so Maven install, it will perform compilation, testing, packaging, integration, and will install the requirements of your project, Maven project, not your build jar, your Maven project. If you think you want to use the project generated in a system to be do in another system, So we need to install the dependencies in your local system. So for that case, we can use install. It will require, or it will retrieve all the required libraries from the central repository, and will you will copy it to the local repository. And clean will perform deletion of previously generated jar files, and a combination of these can be done. So a clean compile will clean or delete the previously generated target files, that is compiled files, and will compile the source files again. And again, compile install will compile the source files before installing. And again, test clean will test the class files after, followed by cleaning. So um, so let's look at how this what are all the operations that are performed in Maven. So when we generate a project, we'll see about how these test cases are all working. So I know it's a bit complex, but I'm trying to tell it in a simple way. So now, for that, to understand that, we need here will I before I told, as I told before, it has main and test folders. So main folders will contain the actual source files what we are creating, and test folder will contain the Java source files for actually testing the code. So here, as we seen before, it's just a printing hello world project, and it's printing hello world project. And this source test file for this project will, for each project test file, will be automatically generated based on the source file, that app.java. So let's look at this app test.java. So what it does is, it just invokes the test, um, invokes this class, and just try to execute it here. In few cases, like if you are gonna execute an algorithm, in those cases, we can just pass a simple data set for the algorithm in this test source file, and we can check whether this source file is compiling correctly or not. So the next step in um, Maven is plugins. So plugin, as I said before, is for special, mm, to do some special work in Maven. For example, by default, Maven uses the Java version source 1.3.3. If we don't need that, we need to use another version of that plugin, version of Java. We need to insert Surefire plugin. And also, for another example, if you want to we know that for while executing a Java file, we need to mention the what is the main class file in a package. So for that, so that it will be easy for the compiler to recognize the main class and execute the project. So in that case, each time we will have to uh, mention the main class file in the execution command line. Instead of that, we can use a compiler. Sorry, uh, compiler plugin is what will decide what compiler we are going to use, and Surefire plugin will determine whether we are going to use the we are going to display the, or mention the class name in the command line or within a POM file. So plugins are used for many purposes, such purposes. So list of plugins include, we can see the list of plugins here. Okay, so this includes a list of plugins for many things. So the Maven goals, what we see now, cleaning, compiling, or searching types or reporting plugins, we should mention in the POM file. So packaging types, as we said before, we have many kind of packaging types. Most probably we'll be using jar in our projects, and still it has rar type, var type, and app client slash ACR, which is a Java and W based environment. So shade, source, everything, and reporting plugins. So reporting plugins includes if basically we have learned about creating reports in Java, so using Java DOM. So in that case, or log files, creating log files. In those cases, if you are gonna use those files, we need to mention. You don't need to include more complex terms in our project. You need to mention these plugins, and we can directly use the log files, and it will automatically create the structures so that the log files as well as this reports can be generated in an easy way. So this change log, what it is it automatically generates a list of changes in our project, and this Java dog, it will automatically generate a Java dog for the project. So everything is bit automated, but obviously it provides a opportunity for us to modify it. That's the basic advantage of Maven. So other, it also provides plugins to include other tools like and is a grandfather of all the building in Java. So it's the first initial tool that came out Apache. Like that, many tools are available. So through that, we can just include them in our form file, and just we can use them as it is. And as I said, archetype, it is also a tool which will generate uh, the project for the project structure. And dependency will include the dependency what we are doing in our project. So let's see how we can compile and run this project. So now we have created a project, and I've already shown you the project will be example. So to execute this project, first we need to enter this directory, the project directory, and if you see here, we'll have this form file and the source file. So to create the, as I said before, we have around 6 goals: clean, install, compile, package, and few others. So compile, what it does is it compiles the source files that are present in the project. Just remember one thing: these reference to all these files will be in the form file. So while executing, while if we are gonna perform some operation on a project, a particular project, we need to get into the directory where the form.xml is situated. So this form.xml here is situated, and we run mv and compile. So it compiled one source file because it is the one app.java is automatically created. Okay. So now it says the build is success. It is successfully compiled. Now the next step is to package. Packaging, what it does is it takes the source file, converts them into class files, and creates a jar named snapshot 1.0.jar, and before that it also runs the test file. So if test files fails, but it will still generate the target file, but you can watch, you can know that your project has some problem, and we can obviously modify it and change it. So now let's take a look at the folder structure of this project. So if you see now in here, an example, along with source, it has created target file. So all the files created during project execution will be stored in here. So it will contain classes, what are all the classes we created, and if we use any external archive files will be here. Surefire plugin, as I said before, if it is used, it will have an XML file stating the main class of the file, and the report regarding this Surefire and the test case classes. So the app test.class will be present here. So now this example 1.0 snapshot.jar is now independent of all the dependencies. Will and this is this can be run in an independent environment. It doesn't need any dependencies. So for running this project, we are gonna have to do a simple step. We just have to do. Okay, so executing a jar file includes. I'm not familiar with executing with Java, so we need to load the jar file. So now we are in this. Okay, we are here. Example and target, and it will contain example.jar. Now we need to mention the class main class file here, svc dot sorry uh, yeah, right. Now it's working perfectly. So the package name along with the class name should be mentioned, and it prints hello world. So this is how we run a project in that is a execute it's a simple structure to execute the project. Okay, so now so for now, do you have any questions? Anybody have any questions so far? So I haven't got any questions so far. So I think we'll move further. Okay. So so now let's see some more information about multi-module building multi-modules using Maven. Uh, okay. So multi-module builds. Um, so far, I've said basic about Maven. So this is also a basic thing. Like, what if we already have a Maven project, and we are gonna have want to include that in our project. So it also includes this case. So a multi-module project will have, if you multi-module include a tag named module, it will contain the module names. Okay. So this will create a folder structure similar to this. So as I said before, in a single Maven project, we'll have a source file along with the corresponding form file. So a multi-module project is one which will have individual projects combined together and into a single form file. For example, in this Maven training and Maven training web, these are two separate projects which are combined here, and the resultant folder structure will be the Maven training will contain its own source and form file, and Maven training web will contain its own source and form file. So these two will be combined together, and those information will be in this form file. So this is building a multi-project module project, but I don't think we actually need to build this multi-module project, because what even already have a module um, such as already existing Maven project to be included in here. As we seen about adding dependencies, we can just add the form file into this the current project's form file, and that's it. We're done. So the multi-module projects will be basically for the larger kind of projects, which will basically industry-based projects. Okay, then. Uh, Okay, let's take a look at other Java building tools. As I said before, Ant is the grandfather of all the Java building tools. It's basically is just a scripting. It's not like Maven where everything is automated, but it we have option to modify everything. So it's basically scripting, but it's very flexible. Then came Ant along with Ivy. So it is basically Ant along with some dependency management features. And Gradle, this is most recent one, and most uh, industry is using Gradle is more percentage is more higher than the using Maven, because Gradle uses Groovy scripting. That is, we don't have to use this XML files. Everything, it is completely automated. But one disadvantage with Gradle is you cannot change anything. For example, we are create if you create a project for an algorithm and you want to test it with your own input with your own way. For example, if you want to test only a single module in your algorithm, you can just provide a test case for that algorithm with a sample input. But in Gradle it is automated, so we don't really have much options like Maven to alter the structure of our project. So it's still in developing stage. Yet developer world, as almost 67% of developers are using Gradle, but research developers are preferring Maven to Gradle, because in research we'll need many options to modify our project according to our needs than just creating automatic project. Okay, so dependencies. Uh, Dependencies in the sense, okay, I'll come from the initial path. So we have, for example, consider we are creating a project to it's an application project. It stores database. Okay, it stores data. It retrieves data from the user. It stores into the database. So in that case, in consider either whether a Linux or Windows-based system will obviously need, if for example if we are going to use MySQL, we'll obviously need a driver for MySQL, and MySQL must be pre-installed in the system. So these kind of requisites. But in Maven, what we can do is we can retrieve the MySQL driver package from Maven repository. We can just add a dependency, and it's done. So we can just use those packages, class files in our project. We can just use it. So the whole driver concept is not needed here anymore. Okay. So to explain more about dependencies, to include okay, so dependencies can be placed in three places. Okay, repositories, basically they are repositories. One is central, second one is system local, third one is project local. Okay, so these dependencies can be added in the form file of a particular project. So it can be added using the dependency tag. So in a dependency tag, we can just mention the project's group ID, artifact ID, version ID, and it's done. So we can directly include the classes within the dependency packages into our own project. So Maven creates an automatic link for that. So in central repository, the Maven has its own central repository, and also it has various mirror repositories alongside the world. In case if you are in US and you have a problem with the central repository, you can use the local US based repository for your reference. So every repository contains the same files with the same information, but each has its own way of representing it. Okay, and local repository is a default one which will be created when the project is the Maven application is installed. Its path is the home folder of the user slash .m2, which will be hidden from the user, and that will contain a repository folder where all the repository files retrieved from central Maven repository will be placed, and a settings file describing what will be the settings in the system for the Maven application. And so Maven artifact. Maven artifact actually represents uh, the project title. It literally represents the project title. So, for example, if you create a project with the group ID svc.ace.app, and if you create, for example, your project title is transportation system, so then you'll create your artifact ID with transportation system. And if you want to include your project in others newly created Maven project, as I said before, you just take out your project's jar file and install it using installing the third-party jars, and you just include the artifact and group ID. So the artifact ID will be here the transport application, and the group ID will be svc.as.app. So this is the use of this artifact. Yeah. So I've already answered this. Benefits of Maven over the other tools will be like basically other tools are not providing the POM based structure. So Maven is basically the POM based structure. It is the only it is the major plus point of Maven. So what are all the dependencies? What are all the additional things you want to add to a project? You can just specify it in few lines in inside the POM .xml file. So you don't really need any other method to include them in your actual project. And the other thing is the way of handling dependencies, because since it is in the central repository, we just need to download few things from the central repository, and it will be placed for the first time. It will be done for the first time in the local repository. So uh, this provides a great advantage, because in other tools we'll have to manually download those things. Even if there is a central repository, we need to for what to say, like in Eclipse, if you consider Eclipse while creating a project, to add a link, first you need to know that link, but here you actually don't need. You can just search the repository for that tool you need. You can copy the dependency tag and you paste it in here. That's it. You don't really have to know what it really means, but it's obvious for a developer. But for basic creating a basic project, you don't actually need it. It is not a must. And as I said before, Gradle is now evolving one, and everybody is moving over to Gradle. But research developers basically they want Maven because of this only reason. It provides for the user. It provides the user with many much more options to modify the structure of this project. The structure in the sense, we can obviously modify our source code, the structure of our source code, and we can actually create our own test files along with our own inputs, and we can actually also modify what kind of resources we are using. In Gradle, everything from source file to test file will be automatic. If you generate a source file, it will automatically generate a test file, and it automatically run it along with the sample input. So it is like the basic difference is like it provides more option for a developer in a developer perspective to focus. He can actually in his view. That's benefits of Maven. So uh, okay, so let's see something about these plugins. As I already said before, Surefire and compiler plugin. So we'll see about Surefire plugin, which will completely take effect within few seconds. Okay, so uh, yeah, so here, if you have a look at this POM file, by default it doesn't have any plugins installed. So let's try this Surefire plugin for mentioning the class path inside the POM file itself. Okay, so initially, so now we have this POM file in read write mode. So in Surefire plugin, okay, so this Surefire plugin will have let's have a look at this form file. Yeah. So, uh, as you said, many kind of plugins exist for different reasons. Compiler plugin will specify what kind of compiler it is gonna use. And sorry, I was mistaken. It's not surefire plugin. It's shade plugin, which will mention what is the class file. So this is the actual plugin tag, and it will be given inside build tag, because this build tag indicates that this plugin must be inserted in the project during building, not during execution, during building. So a plugin will have its group ID and its artifact ID. So in Maven, everything, each and every single tiny thing will have a group ID and artifact ID and its own version, because everything here mentioned here is a already defined Maven project. It's a already defined jar file. So these things will be retrieved from the Maven repository, and execution includes upon execution what we should perform. So phase, this represents that the type is package, and the goal is shade. Shade represents we need to represents that the target file should be the class file, main class file should be here informed here, and the save plugin implementation class file will be this thing. So org.apache.maven.plugins shade resource and manifest resource transformer. So if here inside the main class tag, we have to mention the actual class file of this project. So it will be svc.ace.app.java. So that class will be app. Okay. So now we have saving it. Now it's saved. Now we have to build it again so that the changes will take effect. Here again we'll have to give mvn package. So this will compile the source. If not compile again, oh, I'm sorry, I've given yeah, okay. Or to give the plugin stack. Each plugin should be mentioned inside the plugins tag. So in here in XML, we already know that it's a hierarchical structure. So a plugins tag indicates that it has a set of plugins, and within that plugins, we have separate plugin. Okay, so now here this informs that the plugin here, the compiler plugin, is a default compile, and here every the surefire plugin, everything is included. The surefire plugin is used for test purposes. Okay, and the test is run. This is the test case. The default test file that has been created, it is run successfully, no failures and no errors, and it is not skipped. So if we run this program, example slash target slash, we don't have to, sorry. So okay, this jar, oh sorry, jar. Okay, it appears that jar is not accepting this thing, but if you want to see that, actually I can show you using my own jar processor. It's Hadoop jar processor. So now it's getting printed. So this jar processor is one which is predefined in Hadoop package. So it's a separate tool used for distributed computing. So here, if we don't add it, we literally have to mention what is the class file we are going to use. We can mention it inside the thing also. So uh, this is briefly introduction about Maven. I know many of you feel it complex, but I think at least a few concepts will get into your mind. If you look at the Maven Maven syntax now, it will be probably you might understand it. And according to me, Maven is a very good software because if you compare it to other tools, it provides variety of functionalities and the syntaxes are very many much simpler. Even if you're creating a project for our lab, it will be much more useful and much more easier when we create it using Maven. So just try it out, folks. So uh, anybody have any questions? We have we came to the end of the session. So if you have any questions, you can ask. So any questions? Okay, no questions yet. So then we reach the end of the session. Well, see you with another interesting software soon. Bye.